Hi, this short video is to hopefully just refresh or show you how we would expect the perfect graph to be drawn in chemistry. So just to start off, we have our dependent and our independent variables. Our independent variable is the thing that we essentially have control over and change during our experiments. And that's the thing or something derived from it which belongs on my horizontal or x-axis. My dependent variable, that's the thing I measure or something derived from it. And so that's the one that goes on your y-axis. And so when I say things like something derived from it, it might be that I need to go 1 over that value, or I might need to go with the log of that value or something like that. But that's all I mean. So my thing that I have control over, my independent variable, goes on my x-axis. My dependent variable goes on my y-axis. Now, normally when we're plotting our graphs in chemistry, what we're trying to do is we're trying to plot graphs which follow some sort of mathematical model. There is a mathematical reason for why I am plotting the graph. And we would usually try and make it fit to y equals mx plus c. And so my equations, if it's not going to give me something in the form y equals mx plus c, I'm going to rearrange it such that I have something in the form of y equals mx plus c for me to be able to plot my data. Because then I can get, my value of interest out of it. So it might be that my gradient is telling me something about the enthalpy of reaction. It might be delta H over R. Or it might be that my intercept is the value that I'm interested in. But either way, normally when we plot a graph, we're doing it because we want to be able to get further information out from either the gradient or the intercept. So when I'm plotting the data, I should never connect my dots on my data, because what we're saying is we have our measurements of our data, and we know that for the data that we've measured, it's true there. But if we draw lines between it, we're saying we know something about the data between those 2 points, and that's not how this works. And so what we do is we should just plot our data as dots in an XY scatter. That will be one of the options on Excel. Or if you're going to use Python or something like Origin like this, you just want to make sure that it is an XY scatter graph and no connection of the dots. The only time you might connect dots is if you're actually going to plot this as a smooth line, because you have hundreds and hundreds of data points, like if you were actually recording a spectrum. And then you wouldn't plot the dots, you would just plot the line. That is the only exception. Unless it's a spectrum, you are going to plot the data as data points. And when we've got those data points, we put our line of best fit in. And our line of best fit should only be included if we have a mathematical model for doing so. We don't just stick any old line of best fit through. We make sure that we're following the equation that we're modeling when we do this with data. So under most circumstances, this should be a linear line of best fit. Now, when I'm plotting my data, the other thing I want to consider is the scale that I'm using. There is no point in me having all of my data clumped at the top just so that I can fit 0 on at the bottom. 0 doesn't particularly mean anything. What I should be doing is I should be spreading my data out so that I can get a good visual representation of it. And those values for X and Y, they can start anywhere. They're written on the graph. It doesn't need to be starting at 0 at all. So I want to make sure that my data is filling my graph area. I also want to make sure that my data is presented clearly, and that means that I should have no grid lines. So grid lines are there on graph paper to help you plot it by hand, but when we're using Excel, we don't need them. And so we shouldn't be adding any, and we should even get rid of the ones that are already there. So no grid lines on my graph either. So at the moment, I've just got my axes labeled as X and Y, but when I'm actually labeling my axes, I want to make it clear, and I want to make sure that my units are included on the axes. And so in chemistry, our way that our graphs are presented are set out in a set of rules by IUPAC. They are our governing body for how everything is presented. They're the people that tell us that the mole is the unit of quantity and that our standard pressure is 1 bar. And they say that units should be presented behind a solidus. A solidus is a formal name for the divide sign. And the reason being is we're taking our value of time in seconds And when we plot it on the axis, it's just a number. And so what we're taking our value of time in seconds, dividing it by seconds, so it is just a number. And so our units should always be presented behind a solidus and never in a bracket. The other thing to note is you'll notice my use of square brackets. Whenever I have a reagent and its concentration is going to matter, I should be presenting that concentration in a square bracket, not by the use of the word concentration or concentration of tertiary butyl alcohol in this case. You'll also notice that my units here, moles per decimeter cubed, there is a space between moles and decimeter cubed, and that my decimeter per decimeter cubed is a superscript. The -3 is a superscript. It's not behind a hat, it's not just written flat. And so we're correctly presenting our units there. The other thing we want to make sure we do is that when we've got numbers on our axes, those numbers are clear. So this is an example where I have quite low concentrations of this reagent azulene. And so at the moment I've got my concentration of azulene in moles per decimeter cubed, but it's quite difficult to read these numbers on the x-axis. They all kind of blur into each other very, very slightly, and it can get worse. I've certainly seen worse in my life from students, and so we want to make sure this is clear. And one of the ways we can do that is, instead of having the units of moles per decimeter cubed, we can have micromoles per decimeter cubed, and we change our values accordingly. The one thing to note here is if we determine a gradient, we need to remember that we've got that micromole. Alternatively, instead of having micromole, I can have a multiplier. And if I have a multiplier, it should usually appear behind the solidus. Final thing to think about is our titles on graphs. You don't need to tell me it's a graph, it's fairly obvious from the fact that I'm looking at it. So the one thing we don't need to use is the words "a graph to show." Also, saying exactly what's on the x and the y axis is normally not very helpful. So saying A versus concentration of azulene is not a very helpful graph title either. And so what we want to make sure is that our title is telling us everything about the figure that we don't already know. You can think about it as a figure caption. And so, for example, in this one, I've come up with the title of the variation of absorbance with increasing concentration of azulene. Okay, that's what's on my x and my y axis. But I've said it's in a 1 centimetre path length quartz cuvette in aqueous solution at 22 degrees C. And I've said why we're doing it in order to determine the molar extinction coefficient epsilon. And so I've told you everything you need to know in that graph in order to know what is going on. So just in summary for all of this, my independent variable gets plotted on my x-axis and my dependent variable gets plotted on my y-axis. I should rearrange any equations that I'm modelling my data as to make sure they fit the straight line graph y equals mx plus c. I should make sure my graph fills the area. Axes don't need to start at 0. The numbers are written on, so you don't need to tell me. We don't need little squiggles. If you're drawing them by hand, those squiggles don't mean what you think they mean, and so they're not needed if you're drawing a graph by hand. The graphs should be as clean as possible. There should be no grid lines. Units should go behind a solidus, not in brackets. Powers should be superscripted, not behind a hat symbol or just ignored. You should use square brackets if you're referring to the concentration of anything. You should remember that your title is like a caption and should tell you any relevant details about the experiment that you're doing that aren't already included in the graph detail. And you don't need to tell me it's a graph because that is fairly clear. I hope that this kind of very quick introduction to what I'm expecting in a graph is useful. If you have any questions, please don't hesitate to ask.